Please welcome David Summers and Abigail McPhillips.
Wow.
Oh, gosh.
That is really bright. Okay, how do I stop it from giving away everything?
That's all right.
Oh, it's fine. Okay, it's only on there. Hi. Before we start, a quick show of hands. Who here has written or played around with React Native? Hands up. Okay. Phew, that was really bad. Who was really happy with their testing and how the testing was in React Native? Great. And who thinks that testing is just a complete waste of time? Okay, no, wait, I'm not meant to put my hand up. Okay, good. No one thinks that testing is a waste of time. So that's handy because we're here to talk to you about a thing that we built called Cavy, which is an end-to-end testing framework for React Native. We think it's pretty cool, and hopefully by the end of this you will as well. But before that, a little bit about who we are. My name is David.
My name is Abigail.
There's
There
the
it
mic. And together we are the engineering team at a company called Pixie Labs. Pixie Labs designs and builds digital and interactive products, everything from bespoke e-commerce platforms for coffee subscription services to React Native apps, obviously, to typewriters that type by themselves when you tweet at them. But we're not here to talk about any of that stuff. Instead, we're going to tell you a little bit about what Cavy is, why we think that you need it, a bit about how it works, and if the demo gods smile on us, we'll do a bit of a live coding demo as well, and then talk a little bit about where it's going in the future. Now, when we were planning this talk, we drew straws, and I drew the short straw, which means that I get to do the live demo. And so Abigail will tell you a little bit more about what Cavy is.
Cool. So what is Cavy? Well, this is Cavy. He's not a bear. He's supposed to be a capybara or a cavy. I'm a developer, and I'm not an artist, and I tried really hard with this logo, so cut me some slack. So according to Wikipedia, a cavy is a family of rodents native to South America, including the domestic guinea pig, wild cavies, and the capybara. It also goes on to say that many cavies are promiscuous, forming no long-lasting social groups, although in some species, males maintain harems of 2 or more females. Yeah, this chap. So otherwise, Cavy is our end-to-end testing framework for React Native. Cavy was born out of our strong belief that there must be a simpler way to test React Native components without touching any native code. So Cavy is open source, it's end-to-end, and it doesn't touch any native code at all. And because of that, it works exactly the same on Android and iOS. So it's completely cross-platform. You set it up once, you write one test suite, and it works the same. So it really fits in with the React Native ethos. So why do we need Cavy? Aren't there already enough testing frameworks out there? So I just want to take a little bit of time to talk about where Cavy sits within the React Native testing ecosystem and why you should consider adding Cavy to your testing setup. So just setting the scene a bit, you're an app developer, you're working with React Native, developing your next big thing. You're coding in JavaScript, you're using the debugging tools, the hot reloading, and things are moving pretty quickly. So you've got your new feature, it's ready to go, and you're all set up with your testing with Jest and Enzyme. Looks like all your unit tests are passing, you're testing your stores, you're testing your components, and you're even doing some snapshot testing, which we'll get onto a little bit later. But basically, you're pretty excited, and it's build time. But oh no, there's fire. In fact, there's loads of fires. You kind of thought that all of your components were looking like they were working. They were rendering correctly, and the new feature kind of looked like it was working too, but only on its own. So pulling everything together now means that some kind of your key user journey is now disrupted in some way. Dishonor. Dishonor on you and dishonor on your family. So what went wrong? Let's start with probably what went right. You had your unit testing set up. And this is how we started too. So a little bit of background. Jest is the recommended testing framework, unit testing framework for React Native. It comes with a test runner, it comes with a certain library, and full mocking support. Jest also allows you to do this really cool thing called snapshot testing. And that is where you take an image of your app or a JSON representation of your app in a specified state. You then compare that to a snapshot taken earlier. And if there's any differences between the two snapshots, then your test fails. Enzyme is another JavaScript testing framework that can be used alongside Jest, or with Jest. And it gives you the ability to shallow render part of your componentry and test whether the individual components are rendering correctly. So again, it's really good for unit testing your app. But what about end-to-end testing? So while it was quite easy to decide how to set up our unit tests, we found that choosing an end-to-end testing framework way trickier. So we looked around. There was a couple of things that you can use. We first looked into using Appium. We found that the overhead for setting up Appium to be quite big. It wasn't intuitive to set up, and there was a lot of work. Doing like a lot of work, and it just seemed quite big and bulky for our app. Appium also uses native hooks to access the components through accessibility IDs. So it doesn't work identically cross-platform. The same is kind of true for the Calabash with Cucumber setup. With this setup, you get really nice readable specs. But again, it does use native hooks to access your components, so it doesn't work identically cross-platform. You have to install Calabash iOS, you have to set up Calabash Android, and that's the kind of thing that we thought you shouldn't have to do. So, not finding anything we were particularly excited about, we felt as though there was a gap in the React Native testing ecosystem. We gave ourselves a week of dead time to come up with something better, and hence Cavy was born. So we think Cavy is pretty great, and so do a couple of other people too. And actually, we already know of companies that are using Cavy in production, on their production apps, which is really awesome. So how does Cavy work? I just wanted to give a little bit of technical insight into kind of behind the scenes how Cavy is working before we go on to the demo. And actually, it's quite simple. There's kind of like 3 main components that Cavy consists of. So the first of these is the test hooks, or what we'll refer to test hooks going forward. And basically, these are what you attach to your components to make them accessible in your test. So you can access them, and you can manipulate them. To do this, Cavy provides you with a ref generating function, and that's the generate test hook that you can see on the right. Generate test hook, you pass in as the ref here we're passing it in to the text input component, and this is the one that we'll be wanting to test. So this function takes a string identifier. In this case, we've called it scene.input. But you can really pass in anything there. It's just the string that you'll then use to refer to your component in your test files. Cavy then adds this the string identifier, together with the actual component, to something that we call the test hook store. And this is just like a store of all of your components that you can then access in your tests. So the second thing is the helper functions. And these are the functions like fill in and press and exists you can see on the right. So these are pretty simple at the moment, pretty bare bones. But anybody that's kind of familiar with RSpec or Mocha or Jasmine will be pretty familiar with the way these look, and also the way that the spec file is kind of set up. So for example, in this spec, we're describing something called myFeature. We're testing that it works by filling in the scene text input with the string hello, pressing the button, and checking to see whether next scene exists. So we kind of have just included functions at the moment that we thought were most useful in tests, and they're also the ones that we needed to use for our own purposes. So as I said, it's pretty bare bones at the moment, but it's pretty easy if you want to add your own functions to use in your tests. That wouldn't be a problem. So lastly, there is the test wrapper. And this is kind of the most abstract component in Cavy. And you can see here that it's imported as tester on the top line from Cavy. And further down, tester wraps around your whole app at the highest level, so your app being called my app in this case. And it does a couple of really important things. The first is it basically makes your test hook store, so that's the store of all the components that you want to access, available. And it's imported here on the first line, test hook store from Cavy, and it's passed in as a prop to the tester component. So you've got store equals test hook store. It's pretty simple. The second thing that the test wrapper does is it actually runs your tests. So you can see on the second line, you've got your app spec, which is imported from wherever you decide to store your test files from app spec. And it's again passed into your big tester component as a prop called specs. So it's passed in as an array of specs. And that is basically it. So the test wrapper does a couple of other things behind the scenes, like re-rendering your app. So it re-renders your app between each test. And that just kind of avoids any issues with tests being conditional on other tests passing or conditional on other tests having been run. So like a login test, for example. So without further ado, I will pass on to David for the demo.
Great. Can you unlock your MacBook? Thank you. OK, where is it? It's hiding. There it is. All right. I'm going to, because this resolution is different, I'm going to make some things a bit bigger. All right, that's a good start. And I'm going to make this guy bigger. Better. Cool.
Sorry.
OK, and that definitely needs to be bigger too. Cool. OK. Can everyone see that OK? Does it look good? Yeah, no one's shouting no, so it must be fine. OK, so the first, I've got here a little demo app. It's not super complicated. It just displays a list of employees. You can search for one, and you can tap on them to see some more details about them and see some actions to email or call them or whatever. And this is cool, but now we want to add Cavy to this and write some tests. So the first thing we need to do is we need to add Cavy, and it's just like any normal JavaScript package. We can just use yarn to add it. Obviously yarn, not npm. And there's no need to run React Native Link. It's, as Abigail said, it is all JavaScript. There's no native component to this. So that is that. And then the next thing we need to do is we need to wrap our app in that tester sort of wrapper components that Abigail mentioned. But just first, in case anyone isn't super familiar with a kind of a React Native app code base, I just want to run through all the directories and stuff on the left here. So first of all, we've got our jest tests folder, which of course is full of unit tests.
So many.
All of them. We have our two native folders, Android and iOS, where the native code lives, which we don't need to worry about for this. And then we've got our app folder, which is where all of our actual React Native JavaScript code is. So all of our UI components and whatever else is in this app. And then a little bit further down here, we've got our two entry points, index.android.js and index.ios.js. These are actually both the same. They both just import this main file. There's a random index floating around here that I'm going to get rid of. There we go. And then we've got our main.js here. So sorry, those two index files, that's where React Native goes when it starts your app. So it's expecting your initial scene or your initial component or whatever, which is what's in here. In here we're importing our app registry from React Native, and then we're loading in our main app component, and then we're registering that as the main component for our app. And this is where we're going to start. So we need to change this from just kind of importing that one component into something that has that tester component wrapping around. So first of all, I'm going to import. This is where everything starts going wrong. First of all, I'm going to start by importing the tester and test hook store from Cavy. And then I'm going to create that test hook store. Oh, I heard that hissing. I was like, what have I done? One line in. OK, I would have noticed that, I promise. And then because I'm about to write a React component, I'm going to need to import React and component. Please hiss again if I make any more mistakes, and just leave me guessing. It's fine. No one say what it is. OK, and then I'm going to create my app wrapper class. And what that's going to do is that is going to render our tester. Now, let me scroll down on my notes a little bit here. So the tester component takes a few props. There are really only two that we care about that are super important. One is that array of specs to run. And for now, we don't have any. It's not going to stay that way. But we'll just pass in an empty array. And then it also takes in that instance that we just created of the test hook store. And also, there's a few optional ones. And one I'm going to use here is wait time. And what that does is that just tells Cavy to pause in between running each test example. That's just kind of for the demo. You don't need to do that. But otherwise, it kind of goes a bit too quick. So I just wanted to slow it down a little bit. And then finally, we just render our employee directory app. Look at that, no typos yet. And then I just need to change this register component line to register our app wrapper instead. Cool. So hopefully, where is it? There it is. Hopefully our demo app still works and nothing goes wrong. Great, everything's fine. So everything is still working fine. So now we need to decide on our test cases. What do we want to test? So I think we should test that this filtering works, so test that typing in the search bar actually filters it down. And also test that if I tap on an employee, I get an email button, let's say, as a starting point. So we need to hook up the components that we're actually going to interact with in our tests. So the first one is that, where are we? The first one is going to be the search bar. So let's hook up that search bar. So we need to import that helper function hook from Cavy. Now, if you've ever used Redux before, you'll be familiar with the function connect, which you can use to turn a presentational component into a, what's the word? Data component? I can't remember. And this is very similar. So what it does is it basically wraps your component in another one, which is going to provide some props to it. And one of those is that generate test hook function that we can use as a ref generating function in our test input. So I'm going to call it search bar text input. And you can use any convention here. You can use whatever. These are just strings, right? It's like refs normally in React before they turned it into ref generating functions. And then I do need to remember to turn this export from exporting that class into the hooked version of the same thing. OK, and then we also need to hook up a couple of other components. But to save time, I'm going to cheat a little bit here. And I'm actually just going to clear this out and swap to a tag, just so that you're not bored by me typing loads of stuff. Great. So the other two that we want to interact with are the employee list item. So I've added a ref generating function here. Now, Cavy doesn't yet support having multiple components with the same reference. That would be super useful, especially for things like lists like this. So in this case, for the purposes of the demo, you could be really fancy, maybe only register the first one that renders or something, I don't know. But for the purposes of this demo, I'm just making a synthetic name for this component so that I can use it in the tests from the first name and the last name of the employee for this list item. And then the other one is the action bar and the email button, which we wanted to check that it exists. So I've added another test hook here, checking that the action bar email button, adding that into our test hook store. So just to make sure again, I keep swapping to the wrong one, that everything is working okay. If I hit refresh, everything is fine. Nothing is happening because we haven't written any tests yet. So that is the next step. So I'm going to make a specs folder in here. And I'm going to make a file in it called employee list spec. And specs are just functions. So we're just going to export a default function. It's going to take an argument of spec. And that's what Cavy is going to provide to us. And it's going to give us all of those methods that Abigail showed you. For example, describe and it and all of those things for checking that components are around. And this structure is going to be very familiar if you've ever used Jasmine or RSpec or something like that. So our first one, our example group will say, when we're listing the employees, it filters the list by search input. Now, all of the test cases use async and await. So, for example, the first thing I want to do is check that there is actually an employee on here. One of the employees we're not going to filter away, or we are going to filter away, sorry. And you can see that this is using async and await. And that's because, if you've ever used headless browser, done headless browser testing where you've got AJAX requests and things like that, and when you write your tests where you're sort of checking that an element is on the page or something like that, you know that the testing framework waits for a period of time to make sure that if something needs to render, it's not just immediately failing because it's taking a moment. So it's the same here. All of these are all promise-generating functions so that they can pause and wait for a period of time, which is customizable, before failing the test. So the next thing I'll then do is I'll use the fill-in helper to fill in that search bar text input with a string. And then I'm going to check that that previous list item no longer exists. And then also check that the one that we are filtering for still exists. Great. That looks OK, right? Have I made any syntax errors? Any double quotes instead of single quotes? No? It looks OK. Great. So now we need to add that to our spec list in our main.js. So this empty array, let's import our new function from specs. And then in this empty array, we'll change this and pass that function in. So now, if I hit refresh over here, I can tell that's really bright because I can suddenly see you all. We can see it's kind of quick, but you can see that Cavy is running through and running that first test, and it's passing. Now, I know I'm not really obeying TDD here. Probably should have written a failing test first. But anyway, never mind. Great. So that test is passing fine. So we'll just add one more. So we'll say that which is the checking that email button's there. So let's say tapping on an employee. Check that it shows a button to email them. So I'm going to do a search again and press on it. So here, using all of those test hook names that I defined before, I'm going to add a pause here for a couple of seconds, just to allow the scene to transition from one to the other, so that it looks snazzier. And then I'm going to check that that email button exists. Now, just to prove that we're not faking this, I'm going to make a typo there. It was email button, not email. It's kind of a fake failing test, but there we go. And if I hit refresh again, we can see Cavy run through. It does the first test, which passes, and then it does the second test, which fails, because it couldn't find a component with identifier, actionbar.email. And you can see each time it's resetting the whole app. As Abigail mentioned, it also, if you want, it can clear out your async storage as well if you're using that to make sure that the app is completely reset each time. So now I can just go and fix that test and run it again. And number 1 and number 2, they both pass. Woohoo! I'm a successful developer. So to just kind of round up, I did kind of fly through that, but in 10 minutes or so, we've wired up Cavy, we've added that tester component wrapper, we've added our test hook store, and we've hooked up 3 components. And we've written 2 test examples to use those components that we hooked up. And although I don't have it to demo right now, I promised that that would also work on Android if I swapped to an Android simulator and hit refresh. My machine is very old. It would not manage running an iOS simulator and an Android simulator at the same time. But we managed to do all this despite the fact that actually Cavy is still fairly bare bones. There's only a couple of helper methods there. And we've got a whole bunch of ideas for how we might want to make it better. And so Abigail is going to run through those to kind of pique your interest. OK, oh, great, from the beginning.
Please no.
OK, start again. Where were we? There was the build and the file. Nearly that. There it is.
Yeah.
OK.
OK, so where is Cavy going next? As you can probably tell, we have quite a lot of love for Cavy. And as I mentioned before, other companies do as well. They're using it in production, which is really cool. And that kind of influences where we'll be taking Cavy in the near future. So kind of with like production testing setups in mind, we want to be able to better support continuous integration. That's things like Jenkins and Circle CI, which a lot of you are probably familiar with. And for this one, we do actually have an open pull request on GitHub to add this functionality. So this is going to be coming pretty soon to Cavy. Kind of hand in hand with continuous integration comes the need for better reporting. So at the moment, as you saw in the demo, the test results are just simply logged to the console. And what would be kind of more useful than that would be to output results to JSON. That means you can understand programmatically whether your tests have failed or passed. And that can be fed back into any kind of continuous integration system. So that's about it. Just before we go on to questions, I want to quickly mention that we are actually looking for a junior developer to join the team. So if you kind of interested in this kind of work we do, then please come and grab one of us afterwards. We'll probably be over by the beers. Or you can take a look at our website or drop us an email if we're too weird or scary to come and talk to. So anyway, anybody got any questions?
I'm guessing maybe you meant to use the microphone. I don't know if that's...
Our microphones, so if you're able to shuffle around, that'd be excellent. Yeah.
Come on up.
Oh, God, my eyes.
Hi.
Hiya.
So basically, I have a lot of questions, but the main one is like, from what I can see from the demo, it's like you're wrapping the actual app to do the testing, and you need a computer already set up with Xcode or in the simulator or whatever. Are you like trying to find a way to automate this process for the continuous integration, you mentioned this briefly, but like, how can you test it in iOS if you don't have like a Mac Mini somewhere already set up with everything, with the certificates and everything?
Yeah, that's a good question. There's a couple of things. Firstly, I think that that tester components, you may want to add some stuff around it to configure it to optionally, wrap your app in certain environments or certain conditions, rather than just all the time. And also, as far as continuous integration stuff, I don't actually know, because the people that are using there are some people that have submitted that wonderful pull request to us that are using this in production with Jenkins, and they are testing an iOS app. I'm not 100% sure how they're doing it, but that presumably, therefore, it's possible. So actually, if you take a look on our GitHub and go and find them and maybe ask them, because they have a they have a solution. They know.
They clearly know more than us.
They know more than us about our own library. So yeah.
Hi. Is there a way to use Cavy without putting these test hook refs in my production code?
Yeah. So we chose to use the refs because that was really, in the week that we had to build this, for solving our own problem where we really wanted something like this for the project that we were building. That was the best way that we could find. It is a little bit hacky and a little bit ugly, and we have no answer right now for how to not be peppering those in your production code. I know that there's some talk about accessibility labels being available within the React Native environment so that you could access them in the JavaScript. Because at the moment, anything that uses accessibility labels, which is a very common solution for testing, I think things like Appium use that, that would be less intrusive, I guess, in your production code. But they, as far as we know, from the hunting that we did, they're not accessible from within your JavaScript, and that was what we really wanted. So that was our only solution that we found. So yeah. Anyone else? Awesome.
All right, Abigail, David, thank you very much.
Thank you.
Thank you.